I'm going to be showing you the standard algorithm and partial product methods to solve 43 times 56, a two-digit number by a two-digit number. I'm going to show you side by side so that you can see the similarities between the two methods. I will start with the standard algorithm. I will write 43 times 56 and have it set up for me to multiply. I always want to start with my ones place value, which is my 6 and my 3. So in my partial products, I will write this 6 times 3 because that will be my first partial product. 6 times 3 is 18. I put my 8 in the ones place and I compose my 10. On the partial product side, I can simply write 6 times 3 is 18. My next step is going to be to multiply now this 6 by my tens place value. I can think of it as a 6 times 4, which is 24, and add one more, which is 25. But since this 4 is in the tens place value, I'm actually multiplying 6 times 40, which is 240, and adding 10 more, which is 250, which is why the 5 goes in the tens and the 2 goes in the hundreds. On my partial product side, I am multiplying 6 times 40, which equals 240. If I add my two partial products so far, I end up with 258, which is the exact same number that I have in my standard algorithm so far. Now, as I continue on with my standard algorithm, I'm going to be multiplying by this 5, which is in the tens place value, which means that the value is 50. Now, any number that is a 10 that ends in a 0, such as 50, when you multiply it by a 1, the number in the ones place will always be a 0. So we can place that there. I can now think of these numbers as 50 times 3, which is 150, which means the 5 goes in the tens place for the 50, and this 1 that I compose is 100. On the partial product side, I can show this as being 50 times 3, which equals 150. The next step in my standard algorithm will be to multiply 50 times 40. I can think of this as 5 times 4 to help myself, which is 20, plus one more, which is 21. But since we're doing multiplying tens times tens, we have 50 times 40, which is 2,000, plus this 1, which is 100 more, is actually 2,100. And that's why they go in the place value down there. In the partial product side, I will multiply 50 times 40, and that will equal 2,000. Now, if I add up this second set of partial products, you can see that I end up with 2,150, which is the same that I have there in my standard algorithm. If you look, I have 258 from the first two partial products, and I also have 258 from the first step of my standard algorithm. In my partial products, the second two steps gave me 2,150, where the second part of my standard algorithm did the exact same 2,150. Now I just need to add them all. If I add 8 plus 0 is 8, 50 plus 50 is 100, compose my 100, 100 plus 200 plus 100 is 400, and then my 2,000 does not have anything to be added to. Now, if I'm going to bring this down so that we can add them together, we'll add them together, and I have 0 plus 8 is 8, 50 plus 50 is 100, compose my 100, 100 plus 100 is 200, plus 200 more is 400, and 2,000 plus 0 is 2,000. And you can see that we have the same answers for both. The standard algorithm has a few less steps, but both are very accurate.